Problem 3. The box wrench is used to tighten the bolt at A. If the wrench does not turn when the load is applied to the handle, determine the moment applied to the bolt and the force of the wrench on the bolt. Okay, to solve the problem 3, for the wrench, the wrench being turned to tight the bolt at point A. So we start with FPD. Okay, the first force 52 Newton. Okay, 52 Newton. The force has its component in X and Y direction. So this is our reference, this is X, this is Y. So the force 52 Newton will go downward, okay, in Y axis with the value of 52. (12/13), okay, and the Fx for 52 Newton will go to the right, to the left, okay, with the value of 52 (5/13). Okay, that's the first acting force, 52 Newton. The second force here, magnitude 30 Newton, okay, 30 Newton, also has component of X and Y. Okay, the component Fx for 30 Newton will go to the right, okay, with the value of 30 cos 60. For 30 Newton will go downward with the value of 30 sin 60. Okay, now we're going to see what happened on the bolt. Okay, since that the bolt cannot be tightened anymore, it reached its maximum level. Okay, it will reach its maximum when the force is applied with this magnitude. So when this happens, this problem will become equilibrium. Okay, this rigid body will become equilibrium. Okay, equilibrium, whereby the bolt will exerting the reaction at point A. So what types of reaction, how many unknowns will exerted at point A? So that's the problem. Okay, notice that in this rigid body there is only one critical point, okay, which refer to the bolt. So if we cannot specify directly what types of support that similar to this situation, we can analyze, okay, we can analyze one by one, okay, on how the bolt will react to this 52 Newton and 30 Newton forces. So firstly, we're going to check the reaction in X direction. Okay, so in X direction, we have force 52 5/13, okay, going to the left, and we have 30 cos 60 of force that going to the right. So both forces, okay, will produce a net force. Okay, there is a net force in X direction. So when there is the net force in X direction provided by the action forces, then the bolt at A will provide with the reaction force, okay, with the same magnitude with this force but in opposite direction. So we have the reaction in X, okay, at point A. So the point A will exerting the unknown AX. Okay, we can assume the direction of X, whether it can go to the right or to the left. Okay, or we can confirm the direction by calculating the net force first. Okay, but for FBD we can assume. So to make it faster in the solution, we just assume AX in X direction. Okay, whether you assume it to be to the right or to the left, okay, it's okay. So next, we're going to analyze what happened in Y direction. Okay, as you can see on the rigid body, okay, we have two forces directed at Y direction. Okay, we have 52 12/13 and we have 30 sine 60. Okay, so both will react, both action forces, okay, will act to downward, okay, in Y direction. So it will produce a net force, and therefore the ball at A will exerting the reaction in Y direction. So the reaction will occur in Y direction. Okay, so we have AY. So AY clearly can be seen that will be directed against these both action forces. Okay, so the AY will be react to upward, okay, react to the positive in Y direction, positive Y axis, in order to achieve the equilibrium. So we have AX and AY at pole A, or at point A. Okay, next we're going to further our investigation or analysis on the reaction at ball at point A. So the ball at point A will provide prevention of motion. Okay, the first motion is in translation for X and Y direction. We already show the prevention, okay, by proving there are reaction at X and Y direction. Okay, here we have reaction force of AX and also reaction force of AY. So the next prevention of motion is going to look in terms of rotation. Okay, as you can see from the diagram, from the FPD, okay, both 52 and 30 Newton, we try to rotate, the body at point A. We try to rotate the ball, okay, the ball at A, but it cannot do that anymore because the ball is tightened up to its maximum limit. So the ball will prevent the motion in rotation. Okay, so now the equilibrium is achieved. So what the ball will provide to prevent the rotation, okay, it will provide the moment, okay, or the reaction moment. So okay, we have these two action forces, so both with the same direction and both will produce moment at point A, okay, in this direction. Okay, moment will be produced by the action forces, the two action forces here, with the direction of clockwise. Okay, clockwise. Okay, so what will the ball do? It will react back. Okay, it will react with the moment. Okay, with the moment in counterclockwise. Okay, to prevent or to oppose this moment. Okay, the moment by the action forces. Okay, it's labeled by MA, the blue one. The moment, direction moment produced by the ball, okay, will be labeled as MA also, but I use the red color, okay, to show the difference between reaction and the action, so that when both when both a moment will be summed up, it will equal to 0. Okay, it will equal to 0. Okay, so MA equals to MA. Okay, same magnitude but opposite direction. So the summation of MA shall equal to 0.